So I hope everyone is doing well during this pandemic and everyone is staying safe with their families. So today's topic is about site reliability engineering. If I briefly explain the agenda for today, we'll be going a little bit deep into understanding what is site reliability engineering. So shortly we call it SRE. You must have heard this word in the industry maybe a couple of times. And then SRE has 5 concepts. We call it the 5 pillars of SRE. And then SRE has these terms called SLOs, SLIs, SLAs. We'll be going deep into these and understanding how we can actually practically implement things like this and see how it actually affects a production system in real life. Then there's a new concept called error budgets in SRE. This is an interesting concept when it comes to development, feature delivery, project managers. We'll be talking more on this. And then toil. Toil is more into manual automatable work. So if a person is doing repetitive work all the time, which can be automated, we call it toil. I'll be talking about that as well. And then we'll be talking about if there's time, we'll be talking about how to ensure the successful operation of a production system. I'm sorry about the background noise. There are some dogs barking in the neighborhood. Since we are all working from home, there are a little bit of difficulties on that side. So let's proceed with the presentation. We'll start with the concept of DevOps. I'm pretty sure everyone here must have heard the word DevOps. So how did this start? If we look at this, it's actually 2 words. On one side, we have the developers. And on the other side, we actually have the operations team. So initially, these two were actually separate teams. So the development team actually makes sure that the features get delivered on time. And the operations team makes sure that the features that the developers develop will get pushed to production according to the plan. So these two were actually separate units in an organization. So by operations team, of course, we mean the infrastructure teams, the engineers, the DevOps engineers. It's actually the operations team mainly handles the CI/CD pipelines, the deployment side of it. So the DevOps concept came up where they actually broke the barrier between these two parties to make them into one role. That's why we see this position called DevOps. They actually sometimes know the development side as well as the operation side. So we can't really now distinguish saying, okay, these people are only operations and these people are only developers. No, it's like the full stack concept is coming into play with this role of DevOps. Similarly, I'm pretty sure everyone must have heard the word agile. So this word agile came into place to remove the barrier, to bridge the gap between business analysts and the software engineers. For example, back in the day, when people used to develop software, it was mainly on you get a list of features, you get the outcome, you have to develop it. You actually just develop it, you don't have a say in it. But when it comes to the agile concept, now you actually take part in sprint planning, in retrospectives, in backlog grooming. In sessions like this, you actually get involved in the decision-making process as well. You can say, no, I don't really want to implement this feature, or else I can't implement this feature until this blocker is completed. So you actually get along with the business analysts, the project managers. As software engineers, you will actually blend in with this concept called agile. Similarly, in developers and operations, we have this concept called DevOps. Now let's see where site reliability engineering comes into play. When we talk about DevOps, DevOps is actually DevOps has been a community built set practices. So it's like a set of best practices. Like the DevOps concept has a proper structure on maintaining cloud infrastructure, or how to properly maintain the CI/CD pipelines, the deployments, how to monitor the systems, how it works. These are like a set of best practices that is under DevOps. It's more like a culture. And when we talk about site reliability engineering actually implements these concepts or the best practices, which we call DevOps. That's where SRE actually, so DevOps is more like a skeleton of activities. SRE can implement them any way they want. as long as it's more into a, it's like as long as it works as expected, SRE can implement them the way they want. This was actually a concept. So if I briefly explain the term site reliability engineering, SRE was a concept back in 2004, started by the Google team. So they wanted a separate team to make sure that the systems are reliable, that the systems are running as expected. Why did they want a separate team? That's because they were thinking like, okay, the operations engineers are actually busy with the CI/CD pipelines, the deployments, and the developers are actually busy with the development work. So they decided to get some software engineers from the development teams and put them to work on the operations side. So rather than just setting up infrastructure, clicking on things, documentations, no. What if a software engineer comes and does like do all this work? What will happen? That's what they call SRE. The entire pipeline concept from development to the deployment and maintaining the system, whatever software engineer is actually doing it. So this is primarily a software engineering role in the industry. It is not necessarily a software engineering role as well. There can be quality engineers, there can be infrastructure engineers involved, but you need to have that software engineering mindset to foresee problems, to proactively react on problems, and things like that. So when we go forward, you can actually see more into the practical sides of this. So at the beginning, you might of course think like, okay, it's more like DevOps. Why do we need an SRE? Yes, SRE is the thinking pattern. It's more like the ecosystem where people think in a software engineering mindset to make sure that the systems are reliable. Let's go deeper into this and see how it works. When it comes to site reliability engineering, there are 5 pillars or 5 concepts that I would like to emphasize here. Any organization tries to reduce these problems that they see. For example, if we look at the first box here, this is about reducing the organizational silos. The silos that we talk about here is we have a separate unit called the project managers. And then we have another unit called the developers, another unit called the actual engineering managers, maybe another unit called the DevOps team. We have these kinds of different teams in an organization, but all of them are working towards a common goal. That's to make their customers happy, to produce a reliable system. So we need to think of ways to actually reduce these barriers and make sure that everyone works together as one unit. That is important. And then the second problem that any organization is trying to solve is accept failure as normal. Because even though some managers say, no, this system has to be perfect, there can't be any bugs in the system, you can't really implement the near perfect system. It's like if you want a perfect system, you have to stop all the feature delivery, as well as you have to have no customers at all. Because ultimately, if you have a system like that, that's the perfect system. That's according to the Google SRE book. But that's not reality. You need customers, you need clients. Clients will be building up. As soon as the customer base increases, as soon as you start putting in more features, the systems will try to break. So these things you have to accept as normal. And what's important is how you act upon it. How you make sure that it will not happen again is what's important. And then you need to think about implementing gradual change. Like, okay, some managers actually try to push in more and more features. That's good. That's good in terms of getting clients and making customers happy, but it has to happen gradually in a way where if something goes wrong, that you can maintain it properly. You can actually roll back and work. We'll be talking about how SRE actually helps with these concepts. If we go to the bottom row here, on the left side, we can see another concept called leverage, tooling, and automation. We have seen many engineers. So there are tools out in the market, but some engineers who are not aware of them, or if it's very expensive, we try to develop those tools. That's one way that we can actually do the pros and cons and evaluate whether we can actually pay and use the tools rather than just developing a tool. Or let's say you have things like manual automation work, manual documentations. If you have a lot of manual activities, there are ways that you can automate it. So you can actually spend that time rather than doing labor work, you can spend that time to do something important in an organization. And the last problem that everyone is trying to address is measuring everything. When it comes to an organization, they measure the employees' performance, everything, like even the costs, even the metrics of a system. So if we talk about a software system, we measure the latencies, the customer's user experience, we measure everything. It's always important to measure everything so that you address these problems. Now let's have a look at how SRE, the concept of SRE, can tackle these problems. If you look at the first problem, that's about reducing organizational silos, the SRE will introduce this concept called shared ownership. That means if a production system gets an incident or if it goes down, it doesn't mean that it's the fault of the developer, or we can't just stay here and say, no, the developers will fix it. That's not the concept of this. You need to have a shared responsibility. If it's even the developers who has to fix it, you need to go and support them. You need to go and help them. You need to understand that if something goes wrong, it's our entire system that's going wrong. So we need to have that shared ownership. It is applicable for managers, everyone, not just the developers. And then the second point, accept failure as normal. It's always important that we have this concept called blameless postmortems. No matter what mistake that happens in a system, you can't really blame anyone. You have to ask the question why and not who. You should not find out who did this, who developed that feature and penalize him. No, you need to actually understand why did that happen. Maybe we need to increase our quality gates. Maybe we need to do some more quality engineering or unit tests or things like that. So you need to understand that we should have, as an SRE, we should not have a blaming concept. We have to be very blameless in identifying problems. And then the third point, implement gradual change. Why do we do that? This is because we want to reduce the cost of failure. In a system, let's say you put out all the features at once. Maybe if one thing breaks down, the time for recovery will be very high. So the cost will be very high. The customer impact will be very high. So it's always important to understand that. And the last 2 points at the bottom, leverage tooling and automation. You should actually, from time to time, you need to find out ways to automate certain things rather than just doing it continuously. You should be able to automate things. That's very important. And at the last point, very last point, measuring everything, you need to be able to measure and evaluate the situation of your production system. This is what we call reliability. If someone says your system is reliable, prove it to me. How can you say that the system is reliable? This is why you need to measure these things. So these are just theoretical concepts. Let's dive a little bit deeper into these concepts with examples and see how this is applicable in real life. So the first topic is about reducing organizational silos. Yes. So when it comes to SRE teams actually share the ownership of production with the developers. If something goes wrong, the SRE team will not let the developers do it themselves. They will come into the process and start helping everyone work on this with a shared responsibility. SRE teams also get involved in the development at very early stages. When a feature is getting developed or when it's getting released, the SRE teams actually get involved and start solving these problems at the beginning itself. And sometimes they say that it's always important to get a person who was in the development team as an SRE. That's because that person who comes to the SRE team will already understand the existing code base. They know how the system works. So it's always important to have someone inside the development teams as well who can contribute more in terms of making the systems reliable. And if you look at some startup companies or new companies, we can't really start any product with an SRE team. No, SRE teams will come eventually. And sometimes we all are doing these SRE activities, but unknowingly. Every company has their own flavor of SRE. There's no proper way of doing it. So Google has only highlighted the concepts of doing site reliability engineering. It's always upon us on how to define this and how to do this in our organizations. And becoming a site reliability engineer is kind of an interesting thing. So it's primarily a software engineering role, but you will actually get to touch different areas or different aspects of software engineering. For example, you will be working with system architecture and inter-service dependencies. You will be understanding how services work in a dependent manner. Then it's important to see the instrumentation, metrics, how to monitor certain systems. That's also important. How to act on emergency responses. If a customer is complaining, if the entire system is down, if Google is down, will your system work? You need to act on emergency responses. Capacity planning, change management, and measuring the performance, making sure that your system is available in terms of latency, efficiency. There are different aspects that a software engineer can actually leverage by being a site reliability engineer. The next concept is accepting failure as normal. Let me come up with this scenario. So this scenario is actually from the Google's SRE book. If we look into a scenario like where you are working in a data center, so you have all these data servers, the network cables, you have an entire data center, and let's say one person goes to the data center in the morning with a cup of coffee. So that person goes inside, just checks the servers and leaves the cup of coffee inside the data center and comes back accidentally. He forgets the cup. Then the second person goes in. When the second person goes in, he accidentally slips the cup of coffee and it goes all over the floor. That's all right. No damage has happened. But when he tries to go out to clean it, he actually slips and pulls some of the network cables down along with him. Now this is a downtime because the network cables are down, some of the server racks are down, the system is down. The question we should all ask is, whose fault is this? Is it the fault of the person who brought the coffee, or is it the fault of the person who actually pulled the cables down? He could have just fallen without touching the cables. That's where the SRE concepts come into play. Always make sure that whenever problems happen, you can't really blame someone. You have to ask the question, I mean, when some things go wrong, whose fault is it? It's nobody's fault. It's actually the system's fault because the system allowed people to act in that way. So you have to always ask the question, why did this happen and not by whom? That's why it's important not to blame people, but to fix the system to make sure that things like this will never happen again. I'm a little sorry about the background noise. So in our example that we talked about, yeah, give me a second. And in the example that we talked about, how do you think the system can be fixed? Rather than just blaming the people who went inside, how can the system be fixed? Of course, if anyone has questions or discussions, you can feel free to start a discussion on the chat and just discuss things. I'll also have a look at it. So in the scenario that I explained, we can actually think of ways where we have a security guard outside and we don't let anyone go inside with any liquid items. We can have a protection layer like that. If we had that, this would not have happened. Or else with the network cables, why would someone implement the network cables facing outside so that it can be easily removed? No, it should be either in a protected layer or it should be turned the other side where no one can actually reach it easily. So what I'm saying, why I'm saying this example is for you to understand and see problems in a different perspective. Not that, so problems like this happen, yes, but you need to build up or develop a mindset where you don't really blame people, but rather you will try to fix them and make sure that it will not happen again. Same with any production system. You have to make sure that it's not to blame someone, but to make sure that it will not happen again, even by a customer or even by the developer. You have to make sure that no. So however we do the process, our system will always be checked at every point and the quality will be maintained. That's the level of thinking and the mindset that you need to have. And when it comes to making sure that the developers and the operators work hand in hand in the SRE concept, you need to understand, you need to define certain things based on your system. So the first question I have pointed out here is, what is availability? So when you say your system is working fine, you should be able to define it in a way where you should be able to say that my system is highly available. If you can really say that your system is available, that means you should be able to actually define it and keep it defined. If not, there's problem. So initially itself, when you are putting it out to the market or certain customers, it's always important to keep these things defined. And then how available do you want your system to be? As I said before, you can't really make your system 100% available. So it's important for you to know that you can make it available only to a certain level. We'll be talking about these numbers. So these are clear numerical indicators that we need to know. And also, not by just defining these availability definitions, you should be able to say, if we cannot meet these availability definitions, what will happen? So these things are important concepts when it comes to the area of SRE. And again, I said in the agenda that there are three concepts, three buzzwords mostly, called SLIs, SLOs, and SLAs. So let's talk a little bit on these things. So if we look into what is a service level indicator, SLI stands for service level indicator. And it is actually a metric that we can use to define that our system is running well. So as an example, it can be the batch throughput. If your microservice is handling batches of data, we can say that the throughput is an indicator of how to indicate that your system is working well. Or you can say how many failures are happening in every request, or for a number of requests, how many failures are happening. So that's a way that you can indicate that your system is performing well. And the request latency, that's also another indicator. Similarly, you can have different kinds of indicators to say that, to indicate that your system is performing well. Then we'll talk about service level objectives. This is SLOs, the second concept. SLOs is based on what you defined above, based on what you defined as service level indicators, how much of, like, you have to give a number, like what percentage of time do you expect that this to perform according to a service level indicator. So for example, if I say that my request latency, most of my request latencies have to be less than 1 second. So we know that it is not 100% possible. So we need to at least say, like, no, I can say that my system's request latency is less than 1 second if it, like, during 99.9% of the time. But the remaining 0.1%, I'm saying it can go above 1 second. So any system has these concepts. So it's always important, if you're an SRE or if you're not an SRE, even still, it's important to identify these numbers and keywords. And then we jump into the concept called service level agreements. This is where the legal binding comes. So you sign an agreement with the customer saying, we are willing to provide you a better service where our request latencies are less than 1 second for 99.9% of the time. We then sign an agreement saying, if we fail to provide this kind of availability to you, we will be giving you a discount. So everyone who pays a licensing fee, I'm not talking about the open source softwares. So if you are paying a licensing fee to a service and you're using it, they are liable to make sure that the system is available based on the definitions. If it is not available, they will have to give back a discount on the licensing fee. That's how service level agreements work. I know that some people know about this and some people don't know. So it's like kind of interesting to know that there are things like this also happening in the background while we do developments. If we jump to the next slide. So as you can see, in this example, we are measuring whether our requests are under 300 milliseconds. As you can see on the dotted line, let's assume that that is the 300 millisecond line. And you can see that some of the requests are actually going above 300 milliseconds. So if it's going above 300 milliseconds, we can define that window as violated. That's what we have done in the bottom graph, where we have indicated that in an up-down manner to indicate that, okay, whether the system is up, whether the system is down, whether it's violated, whether it's not violated, based on the service level indicator that we have mentioned above. So based on the service level objective, that means the now 99.9% of the time. So these numbers actually mean something in the real world. if we say that, so this is basically on the risk and availability of the system. As this says on the text on the right hand side, each 9 you add to the SLO increases your cost. And each 9 that you add will lose the comfort zone. Why is that? Because if you have a look at the table here on the left hand side, you can see that 90% means for a given year, you can actually go down, your system can be down or not available for 36% of 36 days of the year. That means around 1 month. That's good, that's comfortable, because if something goes wrong, you have time to actually put the system down and work and fix it and deploy it. But if you go to the last column, last row in this table, that is 6 nines, so 99.9999. That means for a given year, you can only go down for 31.56 seconds. That's going to be very hectic for a team to actually manage and work on these numbers. So that's why it's important to know that whenever you are defining these service level objectives, service level indicators, you need to make sure that there's a compromise between the development work as well as how you satisfy the customers. This is something that SREs are actually maintaining and making sure of. And this is where the concept of error budgets come into play. So these error budgets are not about the, it's not monetary, it's not something to do with money. This error budget describes, for example, on the top sentence, it says once you decide the SLO, that means 99.9% of the time, you get X number of minutes to go unavailable. So based on the previous table that I showed you, if you define a availability of 99.9%, you have 8.77 hours to go down. So that number of minutes that you can go down is defined as the error budget. So the developers can actually do some testing, do some extreme feature work, and they can actually look into these things. They can actually violate, they are allowed to violate 8 hours or so based on your SLO. So that is what we call the error budget. So it's not nice to violate the error budget more than what is expected. Like, so if you do that, that means you are violating it too much and your availability is dropping below your SLO. 99.9% at the bottom you can see here is actually a 43 minutes for a given month. So if you actually do something like an extreme big feature and your system goes down for 43 minutes a month, that's all right, but you have to make sure that it doesn't go above 100%. If that's the case, you will have to start paying the customer discounts. So this is something that the SRE team is very well on top of, and making sure that these things don't get violated, and the engineering teams are working according to these ideas in mind. And also you need to make sure that these error budgets actually get consumed at least a little, up to 50% or 60%, not 100%. Because if it doesn't get consumed, that means the system is not getting violated as it's supposed to be. That means your system is either using a lot of cloud resources, compute resources, and it's performing extremely well. So it's not going down at all. Or else your developers are not actually pushing enough features. You need to always make sure that, yeah, there's a fine line between violating the error budget and not violating the error budget. It should be a balance. It's okay to violate as long as it doesn't go above the expected number of minutes for a given month. So this is a diagram that represents all three of the concepts that I explained. You can see on the top that the service level indicator is there. And the middle one actually shows you kind of like the SLO, which you can mention as violated or not violated. And then at the bottom, you can see the compliance based on the error budget. You can see that if it is getting violated. So at this point in the middle, you can see that there's a big bump. With that big bump, you can see that the error budget is also rising here in the middle. Yes. And then another important concept is implementing gradual change. This is not necessarily related to site reliability engineering, but site reliability engineering actually ensures that this happens. So in things like what you see today, you can see that updates that we push to production should not be pushed as it should be pushed as canaries and not as bulk version changes. So I read this Facebook article once. They said that when Facebook is developing a new feature and putting it out, they actually start by putting it to some of the Asian countries first. They don't really push it globally because they don't want all of their customers to see these mistakes. They're actually okay with putting it down to some of the countries that they have selected specifically, so that if there are issues, the people can complain, they can identify the bugs. Before it reaches everyone in the world, they actually have it small and try to identify and mitigate the problem. This is why deploying in Canaries is important. Maybe the word canary might not be fluent with some of you. Canaries means you have to push updates in parts, the different parts of the deployment. So at a given point, some people will get the new feature, as well as at the same time, some people in a different part of the world will be getting a different the old deployment. So it's like a balance between old and new. And if the new one is performing well, you deploy slowly and slowly, you deploy the new changes to everyone in the world. That's the concept. And also less code change, that means less feature delivery means lesser mean time to recover on failures. When a failure happens, it is easy for you to recover. And the rate of change would also depend on the selection of SLO. So if the SLO is getting violated, as I mentioned in the previous slides, if it is getting violated from time to time, you need to make sure that the feature delivery, the rate of change of code is balanced. If it is getting violated and violated, you can't keep on delivering features to the production system. And then this is also an important concept when it comes to SRE, tooling and automation. So I talked about the concept of toil. So if you look at toil is actually the manual repetitive work tied when running in production, which can also be automated. So for example, let's say I look at the production system early in the morning and I collect some numbers. I collect those numbers and I send an email to the engineering managers early in the morning. I do this every day. It takes around 2 hours of my morning time. But do you think that I can actually automate it? What if I automate and do it? Will that save my time? Will that save the effort of me waking up early in the morning, looking at the numbers, the human errors? Will that actually solve it? So you need to make a fine decision there and think whether it's important for me to automate this and send it automatically, or rather I'm okay with spending 2 hours a day and fixing this every day. So you need to make a decision there and understand, okay, I will try to automate this, or I will not try to automate this. This is the kind of mindset that is required for an SRE. So sometimes the DevOps engineers or the infrastructure engineers might not think of automating something like that. So you can't really say that because, as I said, the concept of SRE is now blended in everywhere. Even though they don't officially call themselves SRE, most people are actually practicing SRE in different organizations in different roles. So if you always see things that you can automate and it's worth automating it, try and automate it. That's the level of mindset that you need here. And of course, on the other side, not all things have to be automated. There are some things that needs human intervention, like you need to make a decision. Also, then in that case, you can think if it is taking more time every day, you can actually implement a machine learning algorithm to make that decision for you. But in some cases, that might not be practical. So it's always a decision that you take based on automating and not automating. So similarly, every SRE has a toil budget. So this is not a huge concept because by toil budget, we mean that any SRE is allowed to do manual work up to like 50%. We expect it to be 30%, but sometimes during the day, you might get some manual work where you have to go to logs and check logs and see what happened. So these are like manual work. So it's okay to do that for 50% of the time. If you do it more than 50%, people will start getting bored. They will get stagnated and they will start not liking their job. So things like that. So it's always important to balance it between 30% to 50% of manual work. And the rest of the time, you need to be doing actual software engineering work to develop fixes for problems and things like that. And as it says here in the last paragraph, a little bit of toil is not actually harmful. I mean, having toil is useful because rather than you just sitting, if you automate everything, sometimes you might even not have anything to do. You might just have to come and just watch the dashboards and all up and running. You will just drink a cup of coffee and just go home. Then you will start getting boring and all those things will come in when you're working. So it's always important that sometimes you have to identify that as well. And automation might be harder than the manual work. Sometimes for a small task, if you try to automate it using 5 or 6 days, it's in vain. You need to understand that compromise has to be made. And also sometimes this toil, this manual work helps the newcomers to orient themselves, to get an orientation. Like when they do it manually at least once, they understand how the system actually works. So in that terms, it's actually important. And the last point, so this is the last concept of site reliability engineering. It's about how to measure things. What's the importance of measuring? And how can you monitor and measure a system? So looking at this, service reliability needs to be measured. Just give me a second. The service reliability needs to be measured. This is actually a major role of a site reliability engineer, where at the end of the day, they should be having proper numbers. They can't just say, okay, my system is available. We are doing well. Nothing to worry about. No. You need actual numerical indicators to say that your system is functioning without any problems. That means you need numbers. So you should be monitoring the system all the time. This can be, these are all automated tasks. So there are different concepts in the industry called distributor tracing, and then there are ways where you can monitor the latencies, and then the error rates of a system. Then you can actually measure the system's performance by monitoring the CPU percentages, memory usages. So there are different aspects that you can have to measure a system's performance. If it is not performing well, you have to make sure that you talk to the developers or the infrastructure engineers and increase the capacities, the cloud resources, and things like that. And this measurement does not really mean something quantitative. It can also be in terms of customer experience. You can see how many customers logged into the system, clicked on a certain button, and logged out because they were annoyed. It's also an important measurement because you need to understand if that is happening regularly, that means your customers are never going past a certain button. So in e-shopping, e-commerce applications that we see online, like eBay and certain other applications, they actually measure these kind of numbers because they want to know how many people add items to their cart and do not check out. Then they check and see why do they not check out. Then people can make important business decisions. Is it because they have a shipping fee, or is it because they have a high price? What if we give them a discount if they purchase more than 2,000 rupees? Something like that. So it's always important to understand those measurements as well. And a certain things that a site reliability engineer normally measures is they measure the uptime of a system. Then the mean time for failure. How much time will it take to fail a system if something goes down? For example, we mostly use Google's infrastructure or AWS infrastructure or even our own data centers. What if one server goes down, one server breaks suddenly? How long will it take for the system to go down? Let's say it takes 10 minutes until the first customer notices it. Is that like that 10 minutes gap, is it enough for us to quickly fix it or replace the hard drive? That is important to understand. And similarly, the mean time to recover is also important. So let's say the problem happened now. How long will it take for us to recover from this problem? That's also an important indicator to understand how to solve a problem or come up with a solution when a problem occurs in a system. So these are the basic concepts that I wanted to highlight in site reliability engineering. You can always talk to us and see, we have an SRE team here in Creative Software. So you can talk to us and see if you have any confusions or if you think that, okay, you need some suggestions, so you can actually give us suggestions and say, okay, it'll be nice if we do something like this. It's always welcome. It's always a topic for discussion. Everyone can learn something out of it. Since I'll just take a couple of minutes to to come up with an example use case so that people will understand. WhatsApp is an application that we all use. If someone asks you, now you know that an application like WhatsApp is completely free. But if someone asks you, oh, you are the developer, or you are the reliability engineer working for WhatsApp, how can you make sure that WhatsApp is working as expected? Or it is working to satisfy the customers? So all of these big companies in the world, they actually have big like large SRE groups monitoring these kind of aspects. So I just came up with my own set of service level indicators to measure these. For example, if I'm saying that my WhatsApp application is working as expected, I actually check the message delivery time. Let's say both phones are actually connected to solid internet connections. And then when I send a message from one phone, it should get delivered to the other phone within less than 1 second. I expect that. So these are like hypothetical expectations. You can also come up with your own expectation. I'm just saying how you should think of systems. So if you're working on a system at the moment, or if you're working with a product, you can actually see a perspective like this on the system's performance. Then you can understand the message throughput. What if I send like hundreds of messages at once? Will it get delayed, or will they all go in the same time? Or will it go in a different order? That's understanding that is very important. In WhatsApp, I have realized that sometimes the message delivery order is not consistent. So that is important. That might be an important measurement for people to say, okay, 99.5% of the time, my messages will go in a proper sequence or proper order, something like that. And then it's important to understand certain other concepts. It's not just about latency, about the batch throughputs. It's also about certain things like image resolution, the compression algorithms they use. So these numbers do not actually need to be an outside measurement. It can also be an inside measurement. Like, let's say if WhatsApp is using a database, some kind of data storage inside, how long does it take for a certain database write operation? You can actually make a number out of it. You can say all of my data write operations, so 90% of my data write operations should finish within 20 milliseconds. So you can come up with your own indicators like this. So I just wanted to explain a sample use case and make sure that you also get that kind of a mindset. I'm pretty sure like most of you must be having that mindset. This is just to emphasize and say that, yes, even in SRE, it's important to have that kind of mindset. If you can think like that, if you can think openly, reactively, and I understand systems problems and work on that, yes, that's the proper way of thinking of a system in a reliable way. You don't necessarily have to be a site reliability engineer. Whatever role you are playing, if you can see these problems, yes, that's a good mindset to have in any role. We are almost approaching the last slide. So this is the starting quote that we see in the Google's SRE book. If you're interested, you can of course read the Google's SRE book. It's free. It's available online. You can at least go through the topics and the main parts. Then you can understand. Yes, I mean there's a huge concept like that building in the industry. So what this says is hope is not a strategy. Some people, like some managers, hope, and sometimes they say, some developers say, let's hope that this does not break the system. You can't really say that. If you have proper quality gates, if you have written proper unit tests, you can't really say, I hope that it will work. No, it will work based on the strategies you have, based on the quality gates you have. But due to an unforeseen scenario, yes, it can break down. Those are unexpected. But if you say, I hope that this system works, that is not a proper strategy. If you come up with that term, you need to actually think for yourself, like, what if I make myself confident that nothing will break? Of course, there's a possibility of something breaking, yes, but you have to be confident. The managers have to be confident. The people who are delivering it have to be confident. And the customers have to be confident that this is not going to break. So that's the important concept here, and that's where site reliability engineers play a major role, to make sure that no matter what gets delivered, no matter what gets requested from the customers, no matter what kind of customer uses it, we have to somehow try and make sure that they will feel that the system is reliable. Building up this strategy is the ecosystem of site reliability engineering. That's about it. That's what I wanted to highlight mainly on the concepts of site reliability engineering. If anyone has anything to add or any questions to ask, you can always open up and ask. I'll just give a couple of minutes. Yeah, then I guess we can wrap things up.
Yeah, so thank you very much, Kate. I think this is a very valuable session for anyone interested working in software development. Okay, so seems there's no questions. So thank you, Kate, and thank you everybody for participating. We'll meet in another Tech Talk session. Thank you.
Thank you.
Thank you.